All right, so implicit differentiation. So the one on the left here, y is equal to x squared plus 2, that is explicitly written in terms of x, or basically y equals. That's how we try to write everything. On the right, it's written implicitly because we haven't said it's y equals, or you could write x equals if you wanted to. So why don't we just always write things explicitly? Because not everything can be. So up to this point, we've only derived functions. Now we're going to enter the realm of relations, which look like this. So not all relations. Oh, you can't read it. So So if you have a relation, not a function, that looks like this, x squared minus 2y cubed plus 4y plus x is equal to 2, you can't solve for x or y so that it's x equals or y equals, okay? So now we're looking at, you get, these are like circles and stuff like this. You get these weird graphs, some of which can look like this. There's some in the book that you'll see, but some look like this, all right? So this is not a function because it would fail the vertical line test, right? You draw a vertical line. Yeah, if you hit it more than once, it's not a function. So it's a relation. So now we can derive relations using implicit differentiation. Sorry? That's it. Yeah. So we use implicit differentiation. Let's say implicit derivatives. Okay. The key thing with this. Yeah. Deriving. Okay, so when we are doing implicit derivatives, you need to look at the variable you're deriving with respect to. So in this first one, we're deriving with respect to x. All right? That's what the dx means. You're deriving this with respect to x. If they match like they do here, it's the same derivative rules we've been using. So what's the derivative of x squared with respect to x? Just 2x. Okay, that's it. But if you were doing something like this, the derivative of y squared with respect to x, you have to use chain rule. Okay? So these don't match. Okay. So they don't match. So we have to use chain rule. So what we do is we go, all right, what's the outside function here? The squared. So chain rule would say drop that down times the inside function, which is just y, times the derivative of y with respect to x, this bit right here, is dy dx. Okay, I'm going to show you a simpler way because when you write dy dx's everywhere, it gets really confusing. So you could just say this, 2y times y primed. All right, that means the same thing. If I just gave you the function y and I said, what's the derivative of y? It's y prime, right? I did. It is. There's one there, right? Why do you what, sorry? Because you don't know what y is. Y is some function. So you have to say what's the derivative of that inside function because there's two functions here. So if I did, here, look, if I changed it to a 3, say this was a 3, you would drop the 3 down. That would have power of 2. And then you would do the derivative of the inside. So you'd get, okay? We're going to try, I know it's weird at first. All right, you will get used to it. Let's do another one. All right. Yep. Where did the what? That's the inside derivative. So the 3 falling down, this is the outside derivative. And then chain rule says you have to multiply by the inside derivative. The inside function is just y. And the derivative of y is either dy dx or just y. Okay? All right, so next function. Now we have a mixture. All right, the derivative of this with respect to x. So, what's the derivative of x with respect to x? It's just 1. We follow the normal rules. Plus, what's the derivative of 3y with respect to x? It's not 3y prime. It's just 3y prime. Because a constant you don't worry about, right? So we just put the 3, and then I say, what's the derivative of y? It's y prime. Yeah.
Yeah, where did one come?
The derivative of x.
Which rule are you using? James?
Okay, we'll do another one. Okay. The derivative of 4y cubed minus x squared with respect to x. So, the y function, what do I have to do? So you drop the 3 down. Yeah. Okay, so the 3, here, I'll write it out. The 4 stays there. Constant, we don't care. We just put the constant right in front. Don't change it. Then I'm deriving y cubed. So I drop the 3 down, so I'm using chain rule. So I get times 3y. Take 1 away from the exponent, which is 2, right? But then chain rule says you have chain rule says you have to multiply by the inside derivative of this. We don't know what y is. So what's the derivative of y? Y prime. So that's the derivative of 4y cubed. Minus, what's the derivative of x squared with respect to x? 2x. Yep. You could have used product rule on that. But what's the derivative? Because these are, you could say these are two functions being multiplied together, right? So the derivative of 4 would be 0, right? Times y cubed plus the derivative of y cubed, which is 3y squared times y prime times the first function, which is 4. But that is just that. Yeah. Does that make sense? And then, yeah, you would write 12y squared y primed minus 2x. Okay? All right. What if you have this? Xy squared. Derivative of that with respect to x. So the first thing, when you look at it, what rule am I using? Product rule, right? Because it's two functions being multiplied together. Okay, so product rule says derivative of the first one, f prime, that's the top one up there. What's the derivative of x with respect to x? Times the other function, which is y squared. Plus, now you do the derivative of y squared with respect to x. What's the derivative of y squared with respect to x? 2y times y primed. Times the first function, which is x. Are we ready? All right. I'm going to word this one differently. Find so find y prime for y cubed plus y squared minus 5y minus x squared is equal to 4. Okay. So if you have addition signs and subtraction signs, that's fine because you can do each one separately. So we're deriving, so when I say y prime, I guess I should say dy dx, right? We're deriving with respect to x. What's the derivative of y cubed with respect to x? So you drop the 3 down times y primed, right? Plus, what's the derivative of y squared with respect to y, or with respect to x? Times the inside derivative. What's the derivative of negative 5y with respect to x? Negative 5y primed. What's the derivative of x squared with respect to x? What's the derivative of a constant? What? Okay, we're solving for y primes. We got multiple y primes there. So get all your y primes to one side and get everything that doesn't have a y prime to the other side. So move the 2x to the other side, essentially. Okay, we're solving for y primes. What do we want to do that? Factor out a y prime. Final step. Divide it all off. And that is your derivative. All right. I'm going to stop there because there's only a few minutes left. And I'm just going to ask you to do number 1 and 3. That's it. On page 145. Just numbers 1 and 3. And then tomorrow we'll pick this up.